Hello for everyone. So today I want to show you this device. This is Sonoff RF Bridge, and what this device do? This device receives RF signals and sends those signals to AV-Link app on the phone. AV-Link app. You can connect various RF devices to this, and if they were triggered, so you receive the notifications on the app that something happened. So let's show you how it works. You connect RF bridge to your Wi-Fi network, and then you connect. You see that this RF bridge is online, and you connect various sensors. It may be a fire alarm detector, or door detectors, or water leakage, or some other, and if I have this RF fire alarm sensor, I can activate it, and I receive over network notification that fire alarm triggered. So this is very useful, that all RF devices you can monitor them on by internet wherever you are. So okay, what is the problem with this device? The problem is that it only works with AV-Link app, as I mentioned, and I want to connect this device to MQTT broker, and that it can send receive data from sensors to my MQTT broker, and from broker to other devices, or my smart home system, home assistant. So that we can achieve that, we need to flash other firmware than is on this device. So it no longer work with app I mentioned, but it sends signals over my network to my smart home system, so I can control all devices, whatever manufacturer it is, on my own smart home system with one app, not many apps from different manufacturers. So it will be very useful. So to do that, first of all, we need to disassemble this device, disconnect, and there is 4 pads. We need to put it off with somewhat like this. and you see various screws. Now we need to unscrew we will flash Tasmota firmware to this device, and this firmware does mostly the same. Only difference is that it sends over the network to my MQTT broker received data. So here we are. We have one button, and we need to pull up this a little bit. So here we have a button. When we will flash firmware, we put it off, and after that on. And here we have paths to connect our USB to TTL adapter. So to flash firmware to this device, you need to have USB to TTL adapter. There you connect to computer, and those pins you have to connect to device. Please pay attention to that USB to TTL adapters maybe 5 volts and 3.3 volts. So in this case I have adapter that supports 5 volts and 3.3 volts. I don't know if you see, here's 5 volts and there is 3.3 volts. So please pay attention that you need to put this jumper to 3.3 volts. And now there is ground and VCC, TX and RX. So here you need to connect to this header, which is first is 3.3 volts, second is RX. You need to have to connect to adapters TX and TX to RX, and ground to ground. So let's go to PC and see what firmware we will be flashing to this device. So now we download the software. First of all, we need to go to this address, GitHub page, ASP Easy page. I will leave a link in description, and download the latest version of release Mega. So it should be this file, ASP Easy Mega, the latest version. Click and download it, and after that you need to extract it like this. And now we need to go to Tasmota GitHub page. Also leave a link in description, and go to releases, and latest version now is 8.3.1 thread. And all the way down. And now here we search for just Tasmota bin and download it to folder where you extracted SPEs mega, and just download it. So now we have this tool. What we need: flash ASP.H266.exe. We can open it and choose Tasmota bin. But now we need to first of all to connect our device to PC to upload the firmware. So as I mentioned, first of all we need to put this to off and connect our USB to TTL adapter to these headers. So here we have from adapter 3.3 volts and TX, RX and ground. So this way we will connect it to this. Like this. And now we need to connect. So to connect in flash mode we need to push that button, reset button, hold it and connect adapter. Okay, and now let's go to PC. So now we need to know to which COM port connected our device. So we need to right click on Windows sign and choose device manager. From here we have go to ports, and we see that our device is connected to COM6 port. So let's start firmware, choose COM6 and tasmota.bin file and hit flash button. A little bit patience and the flashing will start. We need to wait a little bit. The flashing does not take very long. %. And the final, that's it, flash complete. So now we can disconnect our device from adapter and let's try to connect it. Wi-Fi LED is blinking. It's a good sign. So now we have to go to our phone settings, and or you can go to your PC and you will see the access point, something like Tasmota, blah 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 blah. So you connect it. Here you have to enter your local Wi-Fi session ID and password, and then hit save. Then this device will connect to your local network and you can control over your own Wi-Fi. After you save Wi-Fi credentials, the page reloads and device tries to connect to your Wi-Fi local, and when it connects, you need to know what is the IP address of your device. So you need to use some tool. I use Thing, a great tool. You can download it from Android App Store, Google Play Store, and open the app and push the button to refresh, and it scans your Wi-Fi network, all the network, and shows the devices connected to it. So here I have this device, and it has this IP address. So now we can go to PC and configure this device as we want. Okay, so now when our firmware is flashed to our device, we need to configure two main things that this device work like RF Bridge and set up MQTT broker. So like we saw in Thing app, we need to enter here on your browser the IP address of your device, and here we are connected to our device, and we here we see so is device is acting like Sonoff basic model, which is not true, so we need to change it. Go to configuration, configure module. We see that it's selected Sonoff basic. We need to select Sonoff Bridge and save it. Device restarts, and in a few seconds, and now we see the buttons. You can program these buttons to send some RF signals to other devices like relays or something. So now we need to configure one more thing. We need to go to configuration and configure MQTT. So here you need to enter your MQTT host IP address or host name port. It's already entered default port. If it is different in your case, so please enter different. The other options not necessary. If you need to authenticate your device on your MQTT broker, so here you have to enter username or password. In my case, I don't need those, but there is some user, so let's keep it and save. Device restarts, and now we can go to console, and we see that here is some information that device is connected to our Wi-Fi network and connected to MQTT broker. And now I can just press the test button on fire smoke sensor, and we should see the new line from the device on logs that RF signal is received. So let's test. Here we are. I press the button and we receive the signal, time, RF received, some information, and the main thing that we will use is data. This code we will use in our project to on Home Assistant. So when we press the button, so we can know that smoke detector is activated. So that's it with firmware. So now when we configured our device, we can test our MQTT broker. Is it receiving the data? So to do this, you can use any MQTT broker client or your device like Home Assistant, which is using MQTT. I can come here to developer options and MQTT to subscribe to topic that sends our RF bridge. The topic is this, so we can copy just and paste it here and start listening. And if you don't have such, so you can just install Chrome extension MQTTLens. This simple extension that allows you to subscribe or publish topics. I have already installed, so I can show you how to use it if it works for me. Here we are, and you just go to connections and tap on plus sign and add credentials of your MQTT broker, and here you can subscribe or publish some data. So here I have some subscriptions, but I don't need that. The messages came, but I delete the subscriptions. I can now subscribe to the same topic on MQTTLens app. To subscribe, you can paste it here and push subscribe. And now if I push the button on fire sensor, so we have to receive. We see that we receive data on the subscribe topic on my Home Assistant, but this data I don't see. Subscription Tasmota. I think the wrong topic. You have to copy the topic that ends with result, not state. And delete that and subscribe to results. Subscribe the same here. Start listening. So now let's try again. Push the button, and here we are. Here we see the same results as RF Bridge sends to us. So, okay, the practical use. I have here my Home Assistant instance, and here I set up the smoke sensor entity, and also set automation. This automation is about that the fire sensor it only sends information when it's activated. It's not like doors. It some sensors sends information like door is opened and door is closed, and it should be great. It would be great that the sensor send to information like fire smoke detected or smoke already gone. But it sets only one time when it's detected. So when this smoke is detected, so this entity stays on forever. And this is the problem. So I set up this automation that when the sensor state of our smoke sensor changes from off to on, and it for 1 minute. So after 1 minute, the automation sends data to that topic that smoke detector is off. So here is the sensor data, sensor configuration on our configuration YAML file. Binary sensor, platform MQTT, it's a fire sensor, and here we have entered that to get that data from here, not from here, from here. It's RF received and data to grab this piece of code, and when this signal like this is received from this sensor, so then activates the entity and smoke is detected. So, and the automation that I talked sets this payload after 1 minute, and after that, if smoke detector is sending signal, so we have we will get another notification that smoke is still on. So device class is smoke, and so on. So this is it. Now we see that smoke is detected because alarm was activated, and we see that state changes to not detected after 1 minute from time when it was activated. So I have here another automation that this automation when smoke sensor's state changes from off to on, it will send its call service of Home Assistant notify to my phone. I will get notification with message that it's fire alarm and smoke is detected at home. So wherever I am, home or not, I will get notification if something happens at the home. So that is the practical use of all this. In other video I tried to do some interesting thing. I have another device with RF. It's a doorbell. You plug this into mains, and when you press one of these buttons, you hear the sound, some melodies or so from this device. Those buttons sense RF signals, so I catch those signals with this and catch them into my Home Assistant app, and then the button will be pressed at the gates. On the mailbox I will glue this. When it will be pressed, it sends signal to home server, and when the home server grabs image from EP camera near the gates and sends that image to me by email. So when I'm not at home, something want to meet me, he came near the gates, press the button, and I get notification that something is at the gates, and got the image who is at the gates. So I think that would be great, and this will be the good video. So if you want to subscribe to this channel, and you will see more videos like this, and press thumbs up, and leave the comments if something if you have some. So okay, bye.